Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about NASA's VIPER moon rover mission. So let's dive deep into it. So what is VIPER? VIPER is Volatile Investigating Polar Exploration Rover. Yeah, sometimes they get carried away when they're making these names, but that was the whole point, basically figuring out volatiles. What are volatiles here? Anything that changes too quickly. In this scenario, water is our key target. That's what we are trying to, fine tune it. And this is done under the contract of Commercial Lunar Payload Services, meaning NASA has to do Artemis, but Artemis is completely under NASA's control. Of course, rocket is being built by someone else, but NASA is the one that is like sole, they are doing everything. Now, in this scenario, they realized very early on they have to do a lot of preparation work. They have to land some things on moon, they have to do some satelliting on the moon. All those things will require too much money from NASA's point of view if they have to do it themselves. So they are like, hey, we will build the stuff, be it satellite, be it probes, we're gonna build those puppies, but launching of that will be done by commercial partners. Anybody who can show that we can this is the rocket, this is our launcher, we can marry them together and then carry your payload. Good, NASA will use that. So CLPS is the way where NASA can get a lot of research done for very low cost compared to NASA doing it themselves. So NASA will only build the payload, and how the heck you would launch it, deliver it, that would be completely up to basically other players. Exactly how ISS is getting resupplied. The resupply vehicle and resupply rocket, all of them are coming from private sector. Only the material that is inside, that is from NASA. So Griffin lunar lander is selected for this. That is from Astrobotics. Yes, the same Astrobotic whose basically Peregrine lander basically sprung a leak. Then it sealed itself. Then they had to crash it. And you will like, then why they are not cancelling it? Here's the deal. This sort of things are planned years ahead. Years ahead, not 1 or 2 days, years ahead. Heck, the original video is like 2-3 years ago when they were saying that we were selected for it. So likelihood of them cancelling it is not very likelihood, unless even this crashes. Only then they will like, yeah dude, 2 for 2 is not acceptable. So right now a lot of the hope is in Griffin lander, and I can guarantee you Astrobotics is working their ass off to make sure that this does not suffer any issue. And most likely it will be launched on top of Falcon Heavy in November 2024, meaning at the end of tail end of this year, this puppy should be on the moon. And that's all. But there are other missions also that are categorized in the same CLPS. So why we are doing this? Well, basically this is the first time where we're gonna find water. Now you may be bored at this point. It's like, how the heck every mission says we find water on the moon and we are still doing it? Well, we are narrowing down our search. Basically, we detected spectrum signature on it. We detected absolute signatures on it. We detected directly on lunar orbit signatures on it. Then we landed probes on it. That gave us more data. So brick by brick, our resolution is getting finer and finer. We are now damn sure that there is water. Now here's the deal. All of this is hululu until you touch the damn water. So this is the first time it's gonna touch the water. It's gonna drill the damn water. Basically, we at this point in time, there is some guess. Do we get ice sheet? Like let's say you are drilling and there is like, okay, there is a block of ice, or most likely what we're gonna get is like you have stuff and that has water trapped around there. It would be like how you have wet sand. That's what they are expecting right now, or maybe crystallized ice in small powder form that is distributed around there. Again, we have to know. This is the only way we can physically be sure. No, we are not saying that there is water on moon. We know there is water on moon, and this is the location of the damn water. So we have to touch that puppy. So Falcon Heavy and lander and the rover, we have to touch the damn thing. So the rover is a bit boxy. It's 5 feet, as in 1.5 meter by 1.5 meter, 5 feet, basically a golf cart size, but it's tall. This puppy is tall. It's 8 feet, as in 2.25 meters. 2.5 meters. It's tall. It's very tall. Now, whoever designed the wheels on this puppy, they got carried away. So, to give you a context, it has all wheel steering, meaning all of the wheels can rotate individually, independent of each other. Okay, that's good. All that. We do have some cars on Earth that can somewhat try to do that. Then it has driving in all 4 wheels. This we have. All 4 wheels individually, meaning each of them have individual motor and they can rotate only 2 of them, 1 of them, or all 3 of them, or all 4 of them. They have individual throttle on each of them, and each of them also have active suspension, meaning it's not only going to react to it, it can counteract it. For example, if it's going down a slope, it will basically pull up the rear wheels to as much as it can and then push down the front wheel as low as possible, and that's how it's going to maintain a very good, it's like how we tilt ourselves back to going down a slope. Same thing. So it has 4-wheel steering, 4-wheel driving, 4-wheel active suspension. Somebody got like bit carried away. That's why it does not have 6-wheel. They are like going all in on it. So this puppy will be solar powered. This will have battery for the nights, and it has insulation, boatload of it, and it has heat pipe plus radiator. Now wait a minute, we have insulation for winters. Why the heck we need heat pipes and radiators? This is one thing of the lunar side. It's more brutal compared to Mars, because Mars has a temperature range that is tolerable. Moon has a temperature that's way too cold and way too hot way too quickly. So you will overheat, because the sunlight will be falling on you for continuous 15 days. It's gonna cook you. So it needs excessive cooling power in order to manage that. So during the daytime, it needs to not overheat. Insulation will help in that, but they do need a way of dumping energy outwards. If they do not, it will be basically, they might as well melt other things inside. So they do need that. And this will be the first time in history of NASA's rover they're gonna have put headlights on it. This puppy is gonna have light, and lot of it, by the way. And the reason is they are going to the crater bottom, which is completely in shadow all the time, 24/7/365. Always it's in shadow. That's where our best candidate is. That's where we want to know. We want to drill there, and we want to know, does it have it's like a whole stuff we have to collect and then pull vacuum on them to get the water out of it, or it would be ice, then we have to do some other things to it. Again, we want to figure it out. So you need to away us to see the damn thing. So you have headlights, and it can handle 15% grade inclination, which may not sound very huge, but they are intentionally designing it to be realistic. It's like there are some limitations. And the personal favorite part is it can walk itself. Basically, if it gets stuck in, let's say, somewhere where the wheel starts spilling, it's like, bro, I got this. What it's gonna do, lock all the wheels, and then it's gonna, using individual steering, is gonna, it's basically gonna walk it out. That's the whole amazing part of it. Basically, it cannot sink. How we have G-Wagon that starts to vibrate, this is the upper version of it. It's like, oh, I'm stuck. Oh, no problem. I'm gonna walk myself out of here. I really love whoever came with that design. That's very clever. And that's why all the wheels can go into basically a uncomfortable position. The reason for this is, so if it's on a slope and it has to basically run out of battery, it would require it to stay in the sun for too long. But let's say you disable the magnetics of all the motor, it could slip. So they're like, hey, what if we rotate all of them in an awkward angle, 45, 45, 45, 45? Why? It's locked. It will not fall. It will not roll. It does not have to spend energy at that point in time. Very clever. Basically, it can walk out, it can lock itself on an incline, it can manage a lot of incline. So it's very clever design, but it's tall. Let that be very clear. This puppy is tall, 2.5 meters. It's tall. So what about power? Now, for some reason, they are not using RTG, and even stranger reason, they are not using radioisotopic heater units. RTGs are very expensive. They require a lot of enriched materials or naughty materials or radioactively, ludicrously hot plutonium. Basically, they need some hot puppy. There are a lot of lists, only few of them are viable. So it needs that, I get it. But here's radioisotopic heater units, they require very small amount of it, and it's generally this size, like a AAA battery. Not even AAA, AA battery, or D cell if you really want to be damn sure, or have a lot of heat. So generally those are 1 watt or 2 watt heating block. Like, what's the point of that little power? Here's the deal. It's heat, and heat is 100% efficient. So you put that block in a selected location in your satellites or in your deep space probe or in a rover, it will never allow the temperature to go below a certain point. Meaning, no matter what happens, if you shut down all the electronics, does not run a heater, it will still not drop, it will not allow the temperature to drop below a certain point. So if your calculations is right, you plan it properly, you can have a scenario where it's passively in safe temperature. So not doing that heater unit is weird, because again, heater units are used in multiple missions, deep space mission. RTGs are expensive, but heater units are not. Not using heater units is like a bit odd, but maybe it's because of radiation. So atomic energy convention has to be included into that, commercial partners, hulululu, paperwork, bureaucracy. So I do get why I'm not using RTG. RTG is expensive, but heater units are not. So they are relying fully on solar power, fully on batteries, fully on heaters. And it can last 4 days continuously without solar input, basically. Now, like, wait a minute. Isn't lunar night much longer than 4 days? Yes, absolutely. And the way to compensate for that is they are landing on the pole. Pole has some weird behavior. Same way on Earth, we have pole areas that gets like, 6 months of sunrise, 6 months of sunset. Same way here. It like typical lunar basically night is 14 days long, but certain places that they have selected, it can stay there and the night will only be 3 days long, 3 or 4 maximum. And this rover is designed in such a way that on battery power it should be able to last around 3 to 4 days without too much issue. So like it does not have the luxury of like, you know, Mars rovers where they have RTG. Cooling is never an issue. Basically for them, cooling is an active thing they have to do. They do not have to worry about, oh, I got too cold, circuit broke off, or same in Apollo RTGs. But here they have to be very mindful of it. It should be doable, but like they're cutting too close. I'm genuinely confused why they are not using radio or heater units, basically RHUs. What about the instrumentation? Well, there is a lot of instrumentation. One of the daddy instrumentation is this puppy, this drill. So this drill is the regolith and ice drill for exploration of new terrains, Trident. I'm reasonably sure somebody wanted to call this puppy Trident and then they're just like, they put words there to make sense. It's 1 meter long drill. Now, like, why only 1 meter? Well, they thought of doing deeper, longer, but the likelihood of failure also went exponentially higher. And be mindful, during Apollo era, they were trying with 3 meters. It was difficult for humans to do. So a rover 3 meter, so 1 meter was chosen. And again, there is another realistic aspect of it. Let's say you manage a dedicated tool that can drill and you find it. What then? We're not going to send a drilling rig there to drill it. So it's only makes sense till 1 meter. Like, yeah, 1 meter we can expect through technology of current generation to excavate it. But going deeper than that, we are not there yet. Once we have a permanent settlement, then of course we can go YOLO on it. Not there yet. So 1 meter it is. And this drill has a lot of oomph to it. For example, it has hammer drill system that is 250 watts of power. A lot of power. That's a lot of power. And the bits that's going to do, it's 1800 bits per minute. And then in terms of rotary power, it can go up to 250 watts of rotary power, 120 RPM. Not very fast, but more than strong enough, more than oomphish enough that it can actually go where it needs to go. It will not get stuck, hopefully. And when it pulls out, there is a wheel here, brush wheel. Basically, it's going to remove all the junk from it. And that will fall through this. That is near IR volatile spectrometric system. Basically, this is going to analyze the thing that is falling out, because we are expecting we may get crystal sapphires, we may get wet, quote unquote, wet sand kind of structure. So it's going to fall every time it's going to drill, it's going to pull out. It does not do a sample collection. All it's going to do is drop through this brush. The brush will drop it in front of the camera, and then you're going to have the data analysis of it. So it has a neutron spectron system. Why? Well, you are talking about moon. It does not have an atmosphere, meaning cosmic rays goes wabam into it too quickly. So if you can study neutron output of that cosmic collision, you can study a lot of things in detail. So that's there. And mass spectrometer observation of lunar operation. Why is that also there? Here's the deal. This is time we want to be done. We just want to be done with water part. We're like, dude, this is their water. Like this, just go there, take the regolith, pull vacuum on it, get the water done. We want to reach that point. Pull vacuum, basically, we also have to heat it, because again, it's already a vacuum. You have to heat it so water gets a bit too excited. So basically, we want to be sure that there is nothing hydroxyl or this or maybe that. No, water, H2O. And water molecule only. We have to be damn sure about that. So that's why all the instruments are so focused on same thing again and again. It's like, no, if we say water, we found it, like this is where we found water, this is exactly where water is. So that's why they have this Trident drill. So what can we expect in the mission? Mission is 100 days, meaning if they complete 100 days successfully, it will be classified as a success, and after that they will stretch it as long as it needs to stretch. Like same way with the helicopter, Mars helicopter, it was only planned for few flights just to show that it could work. That puppy survived for, like, 70 plus attempts. So that same thing could happen here. But 100 days is the target. Like the mission is approved for 100 days, meaning you should cross this. Any failure before this will be classified as not satisfactory. Let's just put it that way. So that is totaling 3 lunar day and night cycle, meaning you will go from day and night, day and night, day and night 3 times. And distance goal, how much distance is going to cover? It's 20 kilometers. Like, wait a minute. 100 days, only 20 kilometers? Well, it's very slow, and it's very slow by deliberate design. You cannot just write it correctly if it falls over. And you are talking about moon. There is no rescue party here. So slow and cautious approach is compulsory, so to say. Is going to use X-band, as in 7 gigahertz to 11 gigahertz of direct to earth communication. It's not going to talk to lunar reconnaissance satellite. Is directly going to talk to deep space network on earth using this frequency. So that's another way of they are getting the data out. It does have remote drive capability, meaning it's not a rover, smart rover wise, because Mars is 20 minutes away. This is only few seconds away. And you were like, isn't it only 1.5 seconds? Less than that? Well, here's the deal. You are talking two-way communication, and there is a lot of latency in your structure also. Basically, your computer takes time to code data. It takes time to port that data into another package. Then it takes that network traveling packages. All of those things add latency. Again, in each step is very, very quick, but add enough of those stages until it gets out of deep space network, then it's like, yeah, you already wasted few seconds. So it has a remote drive. It's manageable. It's basically laggy kind of controller, but it's manageable. It does have some onboard smart, meaning you're still gonna tell it go there, and then it's gonna basically drive there. It has obstacle avoidance camera in all four wheels and a lot of headlights. So if it finds something that's like, whoa, it can cause issue, it's gonna stop until you force it to go through it, or it will find another way of going through it. So it has some smart, not very smart, but does have some smarts. And if all of these things go perfectly well, we should reach a point where humanity finally touch the water that is not on Earth. So that's the whole point. You have cosmic rays, bam, neutron flux will happen, and that's how you're going to study it. Then you're going to study the temperature, surface temperature, imperial neutron control rate, and H2O band signature. All of those will be available. And the idea is that's what the hell you're going to find. This is the final answer. Where it's like a wet sand, or is it like a ice bearing layer? We do not know. That's how it will be. And the end result should be a map like this, where you can say humans that are landing around the polar area go in this coordinate, x and y coordinate, and this is where you collect your water. So that's the aim of it, meaning if it does work out, it does actually open the door that Artemis could become a stay mission rather than just like wabang. Instead of wabang, you want to go there and stay. That staying requires a lot of resources. If majority of that resources can be coming from moon itself, it solves a lot of problem. So that's our mission aim here. So this was my presentation on lunar rover. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.